Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the fourth video of chapter 6, that is lines and angles. So we are going to discuss the problems, some questions based on the topics which we have covered in the last video, and it was the when a transversal intersects two parallel lines, then what are the relations between the angles formed. Okay, we have seen some theorems also. So based on those properties, based on those theorems, we are going to solve some very good questions. So let's start the video, and please keep my videos till the end, and please like, share and subscribe my channel. Thank you very much. So guys, let's first understand this theorem and then we will go to problem solving part. So the theorem goes like this: lines which are parallel to the same line are parallel to each other. Lines which are parallel to the same line are parallel to each other. We are going to prove it. So the proof. First of all, let's draw the figure. Suppose this is one line, this is another line, and this is the third line, and this is the transversal. Let us suppose this is L, this is M, this is N. So this line is parallel to this, means M is parallel to L, also N is parallel to L, and we have to prove that M is parallel. If this is the case, then M should also be parallel to N. Okay, so what we need to prove? Let us first write to prove. To prove M parallel to N, and what is given? Given is M parallel to L. Okay, M parallel to L and N also parallel to L. So given M parallel to L and N parallel to L. So these are the given things, M parallel to L and N parallel to L. We have to prove that M parallel to N. So these lines should also be parallel. Okay, so we will do it like this. Suppose this is angle 1, this is angle 2, this is angle 3. So when M parallel to L and M parallel to L, then these two are the corresponding angles, and from the corresponding angles axiom, angle 1 equal to angle 2, angle 1 is equal to angle 2. So this is corresponding angles axiom. Corresponding angles axiom. Okay, also N parallel to L, N parallel to L. So from here angle 1 equal to angle 3. Okay, this is also corresponding angle from corresponding angles axiom, that corresponding angles are equal when two lines are parallel. When two lines are parallel and is cut by transversal, then the corresponding angles are equal. So 1 equal to 2 and 1 equal to 3. And let us take this equation 1, let us take this equation 2. So from 1 and 2, what we find? From 1 and 2, we can say that angle 2 equal to angle 3, because here it is angle 1 equal to angle 2, here it is angle 1 equal to angle 3. So from these two equations we can say that angle 2 equal to angle 3. Now when angle 2 equal to angle 3, from the converse of axiom, which axiom? This corresponding angles axiom, corresponding angles axiom. When the corresponding angles are equal, then we can say that these two lines are parallel. So M is parallel to N from the converse of corresponding angles axiom. And this is what we had to prove. We had to prove that line M is parallel to line N. Basically lines means these lines which are parallel to the same line is L. So when M is parallel to L, when N is parallel to L, then we have to show that M is also parallel to N. These two are parallel to each other. So from the converse of corresponding angles axiom, we can say that M is parallel to N because the corresponding angles are equal. Okay, so now let's take the questions of the topics which we have covered in the previous lecture. Alright, so let's solve the questions. So friends, I have taken this question. The question is like this: in the given figure, if PQ parallel to RS, this PQ line PQ is parallel to line RS, and angle MXQ is equal to 135 degree. Angle MXQ is equal to 135 degree, and angle MYR equal to 40 degree. Find angle XMY. This is the angle we have to find. Okay, so let's do it with very simple theorems. With the help of theorems and axioms, we will do it. So first of all, we need to do a construction. What is the construction? The construction is draw a line AB like this, passing through M, parallel to PQ. Suppose this is AB. So the construction is draw a line AB parallel to line PQ and passing through M. So we have drawn the line. Now, since PQ is parallel to RS, PQ parallel to RS, this has been given. Okay, and we have taken AB parallel to PQ. So from parallel lines theorem, from the theorem of parallel lines, we can say that AB is parallel to RS also. Line AB is parallel to RS also. From which theorem? That lines parallel to the same line are parallel to each other. Lines parallel to the same line are parallel to each other, which we have just now studied, are parallel to each other, and we are using that one. Okay, lines parallel to the same line are parallel to each other. This theorem we are going to use here. So AB parallel to RS. Now we have to find this angle XMY. Okay, the question was angle XMY. So if we are able to find this and this, then we can add these two angles and we can get angle XMY. Now let us concentrate in these two lines, PQ and AB. All right, PQ and AB are parallel, and this is a transversal. Let us do when PQ is parallel to AB and which line? XM is a transversal. Then we can write this angle QXM, angle QXM plus this angle XMB. These two should be 180 degree because we have studied it, plus angle XMB. These two are supplementary angles. Okay, so this is the theorem we have studied, that the interior angles, these two, this one and this one, should equal to 180 degree. Or from the one more thing you can do, if you can extend it like this, extend this line like this. So this here we can apply the linear pair axiom. If this one is 135, then this one should be 180 minus 135, that is 45 degree, because linear pair axiom. Now if this is 45, then this also should be 45 degree, because it is corresponding angles. These two are parallel, this is transverse, this is corresponding angles. So from both the cases you can find that it will be equal to 180 degree. Okay, angle QXM, it was 135 degree. 135 plus this angle XMB is equal to 180 degree. So this implies angle XMB is equal to 180 degree minus 135 degree, that is equal to 45 degree. This one we have put. Now this come to this is 45, so this should also be 45, sorry 40, because these two lines are parallel and this is a transversal, let us suppose. So these are the interior angles, alternate angles, sorry, not interior, alternate angles. So this alternate angle should be equal. Okay, so when AB is parallel to RS, then angle MYR should be equal to angle BMY. Angle BMY, this implies angle BMY is equal to 40 degree. Now from 1 and 2, when you add angle BMY plus angle XMB, that is equal to BMY plus XMB, that is equal to angle XMY, and that is equal to 45 plus 40 equal to 85 degree. So this is our answer, 85 degree. Angle XMY, find angle XMY. So XMY equal to 40 plus 45 equal to 85 degree. Alright. And here I had to write interior angles on the same side of transversal. Interior angles on the same side of transversal are supplementary. On the same side of transversal are supplementary. These things you have to write. This gives a good impression that examiners will think that you know the theorem. If you don't write it, then the impression is bad. So you have to write everywhere under the bracket. All right. So this is the way we have solved this question. We have to find out this angle XMY. So we did a construction. We draw a line parallel to PQ. Now as per the parallel lines theorem, when AB parallel to PQ and PQ parallel to RS, then AB parallel to RS also. So now this angle, these are the alternate angles. If this is 40, then this is also 40. Now how did we get this one? This one you can get from two ways. One is you can directly write that these two angles should be supplementary, that alternate angles, interior angles on the same side of transversal are supplementary. So this is interior angles on the same side of transversal, these are supplementary, so this is 45. Or otherwise you can get this one, linear pair axiom. So this should be 180, this is 45, and then corresponding angles axiom. So anything you can apply. So you get it 45. Now you add these two angles, XMB and BMY, so that you can get angle XMY, that is equal to 85 degree. Alright. So I hope you have got these things. Now let us move on to next question. So friends, let's solve this problem. The question goes like this: if a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. Okay, we will solve it. So first of all, let us draw the figure. If a transversal intersects two lines such that okay, let us suppose this is one line, this is another line, and a transversal is intersecting like this. Let us suppose this is PQ and RS, okay, and the transversal is AB. So if a transversal intersects two lines such that the bisectors of a pair of corresponding angles, so corresponding angles are, these two are corresponding angles, you all know. Now the bisectors, such that the bisectors of a pair of corresponding angles are parallel, so you draw like this. This is the bisector and this is also bisector, okay, and these two are parallels. Suppose this is B and sorry, A and B we have taken, AD we take ABCD, so that it will be good, ABCD, okay. So B, this one is E, this one is G, or F. BE and CF are parallel. It has been given here. Parallel. So we have to prove that the two lines are parallel, means PQ parallel to RS. So first of all, let us write what are the given things. Given BE is parallel to CF. BE is parallel to CF. And these are the bisectors. And BE and CF are the bisectors of angle ABQ and angle ACS respectively. Alright, this has been given. Now what is to prove? We have to prove that the two lines are parallel, means PQ is parallel to RS. Now we will prove it. Let us see the proof. So first of all, since BE is parallel to CF, first of all let us write this is the bisector. So since BE is the bisector of angle ABQ, so angle ABE is equal to half of angle ABQ. Alright, we can say this angle should be equal to this angle. These two are equals. This is the bisector. So angle ABE equal to angle ABQ, and that is equal to half of angle ABQ. Okay. Also this CF is the bisector. CF is the bisector of angle ACS. So we are taking this angle, or rather BC we write BCF is equal to half of angle BCS. We can say like this, because this angle will be equal to this angle, and that is equal to half of this angle. Alright, angle AB equal to half angle ABQ, angle BCF equal to half angle BCS. Okay. Now since BE is parallel to CF, and this has been given, BE is parallel to CF, and let us say AD is the transversal. So from here we can write that this angle ABE is equal to angle BCEF. These are the corresponding angles. Angle ABE is equal to angle BCF. Let us understand from here. The figure is like this. Okay, that these two lines are parallel. This is a transversal. So this angle will be equal to this angle ABE. This is the line. So angle ABE is equal to angle BCF. Okay, here it was complete like this. We are only taking these lines. So this angle and this angle, they are corresponding. So from the corresponding angles axioms, we can say this corresponding angles axiom. We can say this, that these two angles should be equal. Angle ABE equal to angle BCF. Now from 1 and 2, and from here, from 1, 2 and 3, from all these three, from 1, 2 and 3, we can say that half of angle ABQ is equal to half of angle BCS, because this ABE is equal to BCF. So this side should also be equal. Half of angle ABQ is equal to half of angle BCS. So this means angle ABQ, remove the half, equal to angle BCS. Now see here, angle ABQ equal to angle BCS. That means if PQ and RS, we take two lines and these are the corresponding angles, these are equal, then this line should be parallel. So from the converse of corresponding angles axiom, converse of corresponding angles axiom says that PQ should be parallel to RS. PQ should be parallel to RS, then and only then these two corresponding angles should be equal. Then this is what we had to prove. So this is proved. These two corresponding angles are equal, so this is parallel, PQ is parallel to RS. Alright. So I hope you understand this question. It was a good question. So now let's move on. So guys, let us solve this problem. In the given figure, if AB parallel to CD, AB is a line parallel to CD, okay, angle APQ is equal to 50 degree, APQ equal to 50 degree given, and angle PRD 127, PRD 127, find X and Y. Okay, then we will solve it. Very simply, using two theorems, axioms, we will be doing this problem. First of all, let us see AB parallel to CD and PQ is a transverse. AB parallel to CD and PQ is a transversal. Then we can say this angle APQ should be equal to angle PQR. Why? If these are parallel lines, this is a transversal, then these are the alternate interior angles. So alternate interior angles are equal. Alternate interior angles are equal in this case. So this implies angle APQ is 50 is equal to this one is X. So X is equal to 50 degree. First problem we have solved. X is equal to, find X is 50 degree. Now second one we will use here. Also AB parallel to CD and PR is a transversal. PR is a transversal. Now we can say this and this complete. So angle APR should be equal to angle PRD. Here also alternate interior angles, same thing. Alternate interior angles are equal. Okay. So this implies angle APR is 50 plus Y. 50 angle APR 50 plus Y, that is equal to 127. This implies Y equal to 127 minus 50, that is equal to 77 degree. This is our second answer. Y, X is 50, Y is 77. So using these two theorems, we have proved, we have solved the problem. We have found the values of X and Y. Alright, let us move on. So guys, this was the fourth lecture of chapter 6, that is lines and angles, and I have discussed some problems. And before discussing problems, we have discussed one theorem, that is lines which are parallel to the same line are parallel to each other. We saw its proof, and then later on, based on these theorems which we have studied in the earlier videos, earlier lectures, and we solved some problems, very good problems, and still there are very good problems left, which I have kept for the special question answer session, which we normally do at the end of the chapter. So still we have some lectures left in the chapter. So please conclude, let us conclude this lecture here only, lecture number 4. From the next lecture we will move on to next topic. Alright, and I hope you are enjoying my videos, and please be connected with my channel, and please like, share and subscribe my channel, so that it reaches to the persons where it is all most needed. Alright, so thank you very much.